Today, what I want to really talk about is I want to talk about something called the theory of constraints, and want to show you one is a short animation, which I think is great, on theory of constraints, and talk just briefly about it and why this is really, really important. When we talk about the concept of big ideas here on the show, we're talking about those aha moments that we have found in our lives, the things that we've done, that we've seen, that have helped us to understand things that we may not have understood before. And one of these is theory of constraints. So what I want to do, and I'll make this a little bit bigger, is I want to share with you a video that I share in my class, my VUCA MBA class, about theory of constraints. And it comes to us from, I believe it is the Theory of Constraints Consortium or Council of Australia. Not 100% sure. I got this animation many, many years ago, and I thought, whoever it is, I want to give them credit as much as possible, because I think they did a great job of showing us visually what theory of constraints is all about. It's a very simple thing, actually, but I want to play the animation because I think it's very helpful to us to take a look at it. Now, what we're trying to concentrate is the throughput of things through the system. And we have 5 different stations where they're doing some work. Each one of these stations has a different capacity, and that capacity is shown below the station itself. And as they're moving these widgets through the system, I want you to notice certain things. First, the lowest or slowest part of the system is station number 3, which can crank out 10 of whatever these widgets are. And at the end of each day, the throughput is equivalent to station number 3, which in this case is, we're going to refer to as a constraint. And you can see that this person in station number 3 is becoming quite overworked and a little bit red in the face. And this is just the last, they're going to show 5 days. So this is the last day. So the throughput for the 5 days will equivalent to what could be done at the constraint. And the key being here, and I want to zone in on what this particular definition of theory of constraints is. Theory of constraints says any system can produce only as much as its critically constrained resource. Were it not so, the output of the system would tend to infinity or 0. Now, this seems to be pretty simple to understand, but the real question is, how do we put this into practice? And why is it important for something like agility or the VUCA world? And the answer is this. Every system, your company is a system. And if you haven't viewed it that way, it's, I encourage folks to do so. And in your system, you will have a constraint or a series of constraints. So if we go back to this particular one, you can see that that our constraint is 10. And the interesting thing about this theory of constraints is, let's say we put in a process of improvement, and that process of improvement was directed to the entire organization. What's going to happen is that, let's say that for whatever reason, we don't make any change to station number 3, but we double the throughput or the output of stations 1, 2, 4, and 5. The question becomes, what is the throughput of the entire system? And the answer is it's still 10. And we need to pay attention to that, because in my practice in agility, if we had 5 different teams instead of 5 different individuals who were necessary to move work from one place to the other, which team do I concentrate on? We tend to concentrate in agile transformations as we try to transform the entire company without looking at the system and saying, where within the system does it make most sense, not only to start, but to put our effort. So I realize, and some of you may point this out in the comments, that this is quite simplistic. And what we do is obviously going to be more complex than this. But we do need to understand it in its simplicity, because it is still something that will affect the systems we work in. And this is what I've seen, by the way, in a lot of agile transformations. Instead of trying to concentrate on the areas where doing intense work is going to produce the most throughput in the system, or the largest bang for your buck, if you want to go with that term, we concentrate more in a scattergun approach. And that doesn't help us much. The other thing that's interesting on this is, even if we concentrate on, and the reason I'm keeping this up on the screen is I want you to see the various capacities, even if we concentrate on fixing, quote unquote, fixing what's going on in station 3. Let's say there's a couple things that we're going to do. One of the things is we're going to, let's just say the simplest thing is to double the number of people who are working at this particular station. Theoretically, now the capacity of this station is 20. Now, if you double the capacity of the constraint, you do not double the throughput of the system, because you're just going to move to the next constraint in the system. In this case, we would go to the next constraint, which is station 4, which is 14. So by doubling what we do at station number 3, we don't double the throughput of the system. We only get a 40% increase in throughput of the system. And this is important to understand as well, because there's a lot of folks out there in the world of Agile who are promising a lot of things. And they're promising that you're going to get a huge increase in your rate of return in what you do by doing certain things. And the problem with that is that those things need to be more directed, and they need to have a better understanding of underlying systems in order to be most effective. And so what I've seen, and what seems to be a tendency, is that people will take this scattergun approach. The other thing that's interesting about a constraint in the system, which this comes to us from Ilya Goldratt, is that when you lose an hour or a day to the constraint, you lose an hour or a day to the entire system. And this, again, it's problematic. So the key with the constraint is that the folks who are at the constraint need to make sure that they're effective, focused, and on task. Because again, if not, if I improve, I can improve the first station by 1,000%. I am still not going to improve any input at all through the entire system. And this has huge, huge implications, as I say in my training, to your organization. It has huge implications in terms of finance. It has huge implications in terms of HR, who you hire, where you put them, how you focus them, who you train, who you spend your time on, et cetera, et cetera, et cetera. It just cascades throughout the entire organization. And the problem that I've seen, and I see Clement is in the green room, and I'm very anxious to bring him on here. Because he's actually shaking his head. Yes, I understand what you're saying, Larry, which is good. But I just want us to make sure that when we're looking at our systems, let's look at them as systems, and let's look at the overall throughput of the system, because you can often optimize pieces of the system or increase the throughput of pieces of the system at the expense of the system. So even though I've increased the productivity of parts of the system, the productivity of the entire system can actually go down as a result. And this, again, is something that's problematic. And it's something that I see over and over again. And I don't want you all to fall into that particular problem.